All right, so my name is Kelly Wright. I'm with LJB. This is a 90-minute presentation that I've cut down to 30. All slides will be available either via email to me, or you can connect with me on LinkedIn. I very much prefer the latter. I think we should all be connected as much as we can. Again, thank you so much for reminding me of that. Okay, so why are we going to clean this data? So part of this came from learning about GIS in an academic perspective, where they give you these fantastic, clean, complete, whole data sets in order to learn how to do GIS work. Well, day one in a real GIS job, you figure out that that is not ever going to be the case. You are never, ever, ever going to have clean data. So we talk a lot about data integrity when we're talking about cleaning, or when we're talking about GIS data in general. We talk about that because it's important to make sure that data is being entered consistently the same way every time, which is why we use domains and drop-down lists so often. Cleaning the data also makes it look more professional. And there was a recent study that determined that dirty data, or data that is missing, missing, incomplete, or inaccurate, can cost U.S. businesses upwards of $600 billion per year. And while you're like, yeah, maybe I'm in public service, maybe that doesn't matter so much. Yes, it does. Your budgets matter. So we want to make sure that everybody is working with the best possible data sets. And we're going to talk a little bit about data fitness as well. From a legal liability standpoint, a lot of the data that we use, especially those who are in public servant, who do work in the public sector, there are legal decisions that are made based off of that data. And if you unknowingly or knowingly omit or change data, then you yourself and the company and or agency you work for may be at legal liability. Another large problem with this is fraud. There's a wonderful book by Mar Monnier called How to Lie with Maps, which I highly recommend, and it talks about how easy it is to perpetrate fraud using cartography, whether or not we realize that we're doing it. And then last but not least, we clean the data because having dirty data makes us draw false conclusions and helps us misdirect investments. The whole point of using GIS, top one benefit of GIS, is making data-driven decisions. And if your data is bad going in, then those data-driven decisions may not be as data-driven as we think. So data cleaning is the process of ensuring that your data is correct, consistent, and usable. And there are going to be links throughout this, and there's 3 pages of links at the end for references, so I'm not going to spend too much time on that. But that is what we're doing here. We're going to ensure that the data is correct, consistent, and usable. So when we're discussing data quality, we have several questions, and I'm sure that you've thought about some, if not all of these, for the majority of your projects. Is the data valid? Is the data fit? Does it fit your needs? Is the data accurate? And we won't get into the rabbit hole discussion of the difference between accuracy and precision, but you also need to be questioning if your data is precise as well. Is the data complete? Are there enough holes in it that maybe you shouldn't be using it for that particular purpose? Is the data consistent? Are dates being put in the same way every time? Are addresses being entered the same way every time? Has somebody spelled Christmas in 6 different ways and you can no longer look at that as a unique value in your database? Is the data outdated? I know when I was doing a project for my master's program, I was using data from 1998. I don't think that's really legit to be using, but unfortunately in the area of sub-Saharan Africa that I was studying, that was the best and most up-to-date data that I could find. Is the data scale appropriate? I know that Megan Jones encountered this during her master's research when looking at national data sets versus state versus county. When you're comparing scales and granularity, it's very important to understand that your data output can only be trusted at the scale, the largest scale possible. You cannot inform national policy with county data, and you cannot necessarily inform county data or county policy with national data. And then last but not least, can the data source be trusted? Because I know that we all understand how important metadata is, but perhaps that metadata does not make it specifically into shapefiles. I have found that that's a real challenge. So basic steps for cleaning data is to remove irrelevant values, get rid of duplicate values, avoid and remedy typos and other string errors. And I do know that these are text-heavy slides because I want you to be able to use these as a reference in the future. So yes, I will be reading a little bit off of these slides. You want to go ahead and convert your data types to make sure that they are all the same. We'll talk a little bit about that in the future. And we want to address missing values because this is extremely important to understand. You do not want to treat 0 as null and null as 0, specifically when you are looking at mathematical, operations upon which you're performing. So common pitfalls that I'm sure most of us have run into are addressing. Addressing has to be the worst. There are 25 different ways that people write addresses. The U.S. Postal Service has their idea of what is correct, and then every single county auditor, every single city police department, every single LBRS system all enters data very slightly differently. So addresses are something that we're going to be looking into a little deeper. Hyphenated words are another one. Maybe a word is or is not to be hyphenated. If a hyphen exists in one word and not the other, those are not unique value, or those are separate unique values at this point. State and province abbreviations, OH versus OHIO. When we start looking even at counties and the difference between counties and parishes, that can be a challenge. We have zip code and zip +4. So I'll tell you right now, don't store zip code as a number. It's not a number. It should not be a number. You do not want to be performing math on your number, on your zip code. And if you are creating web mapping applications in any way, those zip codes will show up with comma delimiters, even if you turn it off. So you want to make sure that you're storing your zip codes as text. We also want to look a little bit at case sensitivity. So understanding that within ArcGIS and within Excel, and this leads right into the next one, variations of unique values. If we look at road versus road versus road versus road, those are not one value that says road. Those are 4 different values. So it's very important to understand, even if you have capital R OAD and then lowercase r OAD, those are not the same. So we need to understand that specifically within the ArcGIS Esri environment, that case sensitivity matters in a lot of ways. And another common pitfall with geodata is the massive number of coordinate geometry systems that we have in the world and even in the United States. I have received some extremely weird data before and learned more in the last year about different uncommon coordinate geometry that I was not aware of before. Other things we need to look at are extra spaces. This is not something that we think about too often. And leading zeros or missing leading zeros. So if you have a shapefile that was storing a series of numbers as a text value or as characters, and it had leading zeros, if that gets exported to Excel, those leading zeros may not come in. And that may be very important when you're talking about some kind of a unique identifier for which you can create a join to a different table. Also, we need to be careful of storing numbers as text. In this particular case, we were talking about zip code. That's really important to store as text. Other numbers you would not want to store as text. You cannot perform mathematical calculations on text characters. Same thing as special characters as text. Don't quite honestly remember what I meant by that. And then coded domains. So this is super common in shapefiles when we are super common in shapefiles when you have exported from a feature class to a shapefile, unless you actually check the box that says use domain and subtype descriptions. All you're going to get is maybe 1, 2, 3, 4, 5. And a really good example of this is fixed type with metadata that comes out of a GPS receiver. Fixed type 1, 2, 3, 4, and 5. Well, who knows what 1, 2, 3, 4, and 5 is if you're working with a shapefile? And that can be a real challenge, especially if you don't have existing metadata with the data that you've been handed. So last but not least, ArcGIS is pretty particular about how you import Excel and other tables into it. It does not like merged cells. It does not like more than one header. And we'll get into that a little bit. But there are absolutely some improper formatting issues when that you need to address before importing into ArcGIS. Oh, really? Nobody can read that, can they? Great. That's like probably the most important thing in this entire thing. All right, before you clean plan, understand the data before you change it. I get it. We're not aeronautical engineers. We're not police officers. We're GIS people. But before you start changing values, you better understand what it is that you're changing, because that data is critical to the end user, and you want to make sure that you are not altering its meaning or its context. Because something that I really like to drive home is that data becomes information with context. And in our case, that context is the spatial location, but you also need to make sure that you're not just giving someone data that they cannot interpret into information, because data is just ones and zeros. Information is how people make decisions. So this bright orange blob here, what it says to me, let me see if I can see it on my other screen. No, that's not it. I hope I didn't mess up. Can we still see my screen? All right, basically it says, make a copy, okay? Don't work in the original data, ever. Under zero circumstances, save a copy. Do not work in the original data, and save often. So this goes hand in hand with the fourth one, which is save often and create new versions at key milestones. If you get something to work, save it, and then open and do save as and open a new copy. You do not want to overwrite something that works and then you don't remember what happened, which is why it's very important to record all the data transformations that you make in the order that you make them. Order is very important when you're working in Excel. The field upon which you do a sort or filter can dramatically impact the resulting data that you get. So record all data transformations. But this bright yellow one says make a copy. Do not work in the original data. And I have too many horror stories of my own about why you want to do that. So now we're moving into Excel. Setting Excel up for success, you want to make sure that all your columns and rows are visible. You want to remove any filters and formatting. You want to unmerge cells and isolate a header row with some meaningful field names, because understand that when you're working with a shapefile, you don't get the alias, you get the actual field name. So try and make your field names meaningful. And then you want to make sure that you only have one row as a header, otherwise you're going to get a new blank weird record that might actually prevent your data from coming in correctly. So when you are working in Excel, you want to manipulate your columns before you manipulate your rows. And you always want to do work in a new column. So what this means is if we're using text to columns or if we're doing a calculation, insert, right click, insert new row and work in there. Do not work in the original data. And last but not least is use keyboard shortcuts. I cannot stress to you enough how much time this is going to save you. So the next 4 slides are keyboard shortcuts. And I'm not going to go through all of these, obviously. If you don't already know Control A, Control C, Control V, and Control Z, which is undo, you need to know those. There are several that you need to know, but those are the ones that are probably the most commonly used. There's some additional ones. Control.home or Control and End, those will take you to the end of a worksheet or to the end of the text within a formula bar. So all of these shortcuts are designed to reduce mouse clicks on the screen. Control Page Up moves you between worksheets in the same document. Control Shift Space is a very common, great one. It selects all cells that contain data. Shift space is for an entire row rather than you having to drag across the entire screen. And Control Shift Arrow will move a selection to the last non-blank cell in the same column or row. So that's just a really good way of making sure that you can that actually helps you identify where there's gaps in your data as well from a troubleshooting perspective. And then these hidden rows like this, I can't stress to you like the importance of removing filters and hidden rows. Like hidden data, when that comes into ArcGIS, can really break some stuff. So we want to make sure that we're not doing that. And then Control Shift Tilde applies the general number format. And we're going to talk a little bit about numbers, but this is one of the shortcuts that you can use for that. So again, I apologize for the brevity on these slides, but we have a lot to get through in a very short amount of time. So your very most powerful tool in cleaning data is your sort and filter tools. Sorting doesn't change the values at all. It just puts them in a particular order, and you can choose what order that is. It can reveal problems that are caused by extra spaces or misspelling, and it's a very quick way to see how Excel is bucketing or categorizing the data. So this is a really good way to find that, that you've got too many unique values in one place, but a faster way to do that is to use your filter tool. This allows you to see an immediate list of all unique values in a column. Oh, thanks, Andrew. A very great way to see the immediate list of all unique values in a column. So if somebody spelled Christmas 6 different ways, or if they spelled the word government wrong, or if they had a capital or had an extra space at the end, if you see the word government listed 6 times, you know that those are 6 unique values according to the data itself. But I've done this also myself too many times. You do not want to copy and paste when filters are applied. So that's why removing filters before you actually begin the process of data cleaning is a very good idea. Up at the right-hand corner of each of these tabs, it'll tell you within Excel where you can find this. So this is on the Home tab and the Sort and Filter button. This is assuming that you're using a version of Excel, the ribbon-based, like other Microsoft products at this point, and I'll have a couple of screenshots in here later. While sort and filter are really important, I actually think that find and replace is the most important for cleaning dirty data, because this allows you to, once you've identified what your different unique values are, this is one way to go in and make sure that you've replaced them all with one value that is truly unique. This also helps you remove spaces. So in this particular case, I could be finding NW space, 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 and replacing it with NW no space. And then I could do NW space, space, and do the same. And this will help you remove extra spaces. It's also a really good way to standardize your spelling in case and maybe any abbreviations that some people may have been using when entering data. And this is the whole concept of data integrity. You want all of the data to be recorded the same way so that you can make meaningful queries and filters of the data itself. You find this Find and Replace tool either by Control F or Control H, or on the Home tab and Find and Select. And if you look at the screenshot here, you have quite a few options, which we have not opened up to show, but it's an extremely powerful tool. Now that said, at the bottom in italics, consider the implications of replacing. Okay, so we have to interpret the data, we have to be stewards of the data, but we may not understand what the ultimate end use of the data is. So don't be willy-nilly with your replacements, and think a lot about what the implications of changing the underlying data may be. So this is the additional information about the Find and Replace tool. If you do Go to Special, which is F5 on the Find and Select, it allows you to find all blanks. You can look for conditional formatting. Using conditional formatting in terms of color in order to help you organize your data is really useful. Of course, you want to remove that formatting before you import anything into ArcGIS. It also allows you to find formulas, so find cells that are filled by formula. This is important because we want to make sure that all cells are filled with values before importing into ArcGIS. So again, consider the implications of replacement, and I highly recommend, there's a lot of information online about how to appropriately use these tools. Probably second most important to me is the Find and Remove Duplicates. I am sure that we are all familiar with this from using ArcGIS, and I will say that ArcGIS Pro does now also have this tool included, the ability to find and remove duplicates depending on the license level that you hold with your with ArcMap or ArcGIS Pro. So you can highlight duplicate data, which is probably what you want to do. You don't necessarily want to just blank delete, because there may be a reason why data is duplicated. And you can also select what items you want to check to be whether or not they're duplicated. So for example, if everything's the same but the object ID is different and you don't want to replace that, you uncheck object ID, and then that would not find that as a duplicate. Or I may have spoken wrong there. I think if you check object ID and then none of the others, then I think you get anything that has a duplicate object ID. So the problem with removing duplicates is that it permanently removes them. So you do not want to get rid of your original data. You want to make sure you're copying the original cells to a new sheet or a workbook. Again, multiple versions, and try and name them useful. You don't want the final A, final B, like that's my MO, doesn't work, don't do that. A lot of times what you can do is put a date timestamp at the end of your file name. For now, it would be 11/18/2020 1152A. That's a pretty unique identifier for when the latest version was created. And also, this removing duplicates is a great way to generate a domain, a drop-down list, to see what all individual values there are. So finding and removing duplicates too. I unfortunately am running out of time, so this one we are not going to get into. This gets a little, this talks about using conditional formatting to find duplicate values, and that is a little bit more of an advanced technique, so I highly recommend that you review that before using it. And then this gives you the different options for all the different ways that you can find and remove duplicates. So you can see we can go by color scales, you can develop rules, and you can manage what rules you've created. So let's see, fill down and flash fill. This is something that you need to be very careful about, because if you want to auto increment and you don't grab multiple cells that are already auto incrementing and you flash fill down, you are overwriting with the value that was in the last cell. So it is a really good idea to make sure that you're using the special options here to decide if you want to copy the cells, if you're filling a series, if you want the formatting, or if you just want to flash fill all the way to the bottom. And that's when a pattern is sensed. I don't recommend automatic stuff because we need to be very specific about our data, about the data that we're changing. So again, Home tab, Fill, Data tab, Flash Fill into 2016 version, and then Control D and Control E. Or you can just double click on the lower right hand corner of a cell, get that little blue box to appear, and then drop down your values, drop down your contextual menu to choose which cells to copy. You can choose, this is more about series. I had forgotten that this was an interactive slide. And you can look at the different types of autofill that you're looking for, how many steps you want them to. So this is kind of easy or helpful for maybe developing perhaps some kind of unique identifier. So formulas themselves, there's a formulas tab in Excel, and then there's some, you've got your recently used, you can save some to those that you use very often, but the way you use a formula is you put your cursor in a cell, you hit the equal sign, and then Excel begins to suggest formulas as you type. You can also go to the formula tab and say show formulas, evaluate formulas, formula library, or error checking. One that we've talked a lot about here is using the case formula. So we talk about camel case or proper case, all caps, no caps. So we want to make sure that in order for ArcGIS to be able to recognize a value as unique, we want to make sure that they're all spelled the same. So Columbus, it's spelled the same right here. These are all the same. They're spelled the same, but Excel and ArcMap will not treat these as one value. So you want to make sure that you are using your lower, upper, and proper case formulas appropriately. I like the proper case myself. I think that's a really easy one to use, and that makes camel case or sentence case where the first letter of each word is capitalized. Spaces and non-printing characters. The only one I'm going to go over on this is trim. You can come back in and look at these yourself. Trim removes leading, trailing, or extra spaces from a text string. So this is also kind of a handy one to use. And I believe that when you use trim, it asks you how many spaces you want to come in, but that may be left, so I'm not sure. A very common issue that we have in GIS is numbers stored as text. So I'm going to suggest probably the easiest way is the bottom one, okay? You want to paste special and multiply. So you're going to create a new field, and then you're going to just create a formula where you are multiplying the value of the column by 1. And that is going to turn anything in that column that is numeric in any way into a number, and then you will have numbers in the resulting column. Fixing dates and times, as we know, Esri has some specific date types. Excel has some different date types, but there are several tools within Excel to help you identify and make sure that dates are being recorded in the same way. You can also use find and replace for the dash versus slash for dates. And then if you really want to get crazy into this, you can actually develop formulas that will strip out just the day, just the year, just the time, or just the month, and put that into a new column for you. Extremely important tool is called text to columns, and this allows you to split a text string into more than one column. So if you have one column that's all addresses, but your GIS system needs you to have it as address number, street direction, street name, street suffix, zip code and then state and or country, you can use the text to columns in order to parse that out into separate columns. Remember that if you are using a particular delimiter, for example, if there's a dash, if a dash is your delimiter and you have somebody who has written a hyphenated word in there, it's going to actually create multiple columns. So it's very important that you consider the implications of what happens when you run this tool before you do it. I have ended up with some extremely weird data that was like 29 columns got added because I wasn't paying attention. So it's very important, and you want to practice with this tool as well. And we talked about left and mid. So basically this just returns first characters out of a field. It's another way of parsing data out that doesn't use the text to columns or common delimiting spaces. Left returns characters, you choose the cell and then the number of characters that you want from the left. Mid, you choose the cell, the start position, which would be 1, 2, 3, or 4, or so on, and then the number of characters that you're looking for. And right returns the last characters, and I believe you can choose the number of characters from then. Len is a good one. If you are expecting a zip code field to only have 5 characters, you can run len on a in a new column for a previous column of data, and it'll tell you the number of characters and allow you to sort based off of that and find out where there may be some inconsistencies. And then we have concatenate and ampersand. So there's concat, which is the new one. There's concatenate, which is the old one. And then there's ampersand. So concatenate is a fancy word for saying you're going to combine a text string or numeric string from one column and another column into a new column where the two of those are together. And you can also choose whether or not you put in spaces. And that's what some of these formulas show you here. So I do wish that I had the opportunity to go into this a little bit more. Unfortunately, we are right at the end of our time. We want to make sure everybody has a chance to get to lunch. So you're welcome to reach out to me via email, which I have here, via LinkedIn. And these slides do actually have references to a series of web articles and videos that I highly, highly recommend. So with that, does anybody have any questions before we break for lunch?
Kelly, that was amazing.
I'm sorry it was so fast.
It was speed. I'll play fast speed later and get all of it. I do have one question. If people need to go to lunch, totally fine. I don't see any others in the chat, but I was wondering, as far as time management, how much time can you expect spending cleaning data? And what I mean by that is, like, you'll get a project and it'll have a data set, and the project manager will be like, you can have this done by tomorrow, right? And then you open up the data and you look at it and you're like, whoa, this is going to take some time to clean up and get in there. So how do you estimate how much time you're going to spend on cleaning data for a project? Is it how many entries there are, how complicated the data is?
Some of the things that we clean data for is when we're combining multiple data sets into one. And so that is the number of data sets, the number of records, the number of columns. So number one, never make a promise until you open the data and look at it. The answer is always, let me take a look at this and I'll get back to you in an hour with an estimate of how much time. Then you're going to estimate how much time you think it's going to take. Then you're going to multiply by 3. And I'm not being facetious, like, that's for real. Because if you set an expectation that you can have it done in an hour and it takes 8, then you're looking bad. If you tell somebody it's going to take 24 hours and you get it done in 8, you look really good. So I would generally overestimate the amount of time that you're going to need, because you don't want to do this once you've already ingested it into the GIS. You must do this beforehand. So I would say for a lot of the projects that I do as a consultant, people send me their legacy GIS data and we create databases for them. It takes forever. It takes more time for me to clean the data and better understand it than it does for me to actually develop a schema, import the data, create a web map and web mapping application, and publish it to the internet. So I highly recommend that you have that you set aside probably 25% of your anticipated time that you think it's going to take, in order to clean the data. But number one thing is do not promise anybody. If they say how long this is going to take, I don't know. I need to look at this data and I'll get back to you with a more reasonable, with a response tomorrow morning or in an hour, or give yourself a reasonable amount of time. Don't overpromise. I'm not saying constantly underpromise, but don't overpromise, because that's just going to stress you out and you're going to miss stuff. But data cleaning is probably the most labor intense part of other than, manual editing and, digitizing from georeferenced plans. It's probably the most labor intense portion of creating a new GIS.
Thank you. And lots of thanks in the comments. So this is something that all of us are having to do. So this is very helpful. Thank you.
Thank you very much.